Welcome to the lecture video on the subject BT362 Sustainable Energy Processes, and we will be dealing with Module 6 Fuel Cells. The topics we have discussed in the last session was fuel cells and its classification, and today we will be discussing on Magneto Hydrodynamic System MHD, that is its principle, construction, its different types, its applications, limitations, and advantages. So let's see what is an MHD system or MHD power generation. In 1940, Bela Karlovitz received the first patent in magneto-hydrodynamic generation. So the magneto-hydrodynamic generator, MHD generator, is a device that converts thermal energy of a fuel into electrical energy. And the word magnetohydrodynamics, MHD, is derived from magneto meaning magnetic field, hydro meaning liquid, and dynamics meaning movement. That means the MHD power generation is a new system of electric power generation which is said to be of high efficiency and low pollution. So that is the best advantage. It has got high efficiency and low pollution. It's a new system of electric power generation. And this MHD system is mainly concerned with the flow of a conducting fluid in the presence of magnetic and electric field. As we have studied earlier that Faraday's laws of electromagnetic induction, and the principle was whenever a conductor is placed between a magnetic field, a voltage is induced due to rate of change of magnetic flux. So instead of placing a solid conductor, we are placing a liquid conductor or conducting fluid, and the fluid may be gas at elevated temperature or liquid metals like sodium or potassium. So these are the metals we are using. It may be hot gases like natural gas or coal or hydrogen. We are using all such gases. Other than that, we can use liquid metals like potassium or sodium. And MHD is a study of dynamics of electrically conducting fluids like plasmas, liquid metals, and salt water electrolytes. So according to Faraday's law, when a conductor is moved across a magnetic field, a voltage is induced in it which produces an electric current. So in an MHD system, what is actually happening is that the solid conductor are replaced by gaseous conductors. Here you can see the figure of an MHD power generation. There is a working fluid plasma, that is the liquid metal or the ionized gas which we are going to pass through the generator. And in the generator, it is of magnetic field, right? So it's composed of it consists of magnetic fields, and it has got two walls, that is a cathode wall and an anode wall. So when this ionized gas is passed through the between the magnetic fields, what is happening is that the outermost electrons of the working fluid or the ionized gas get released out of the outermost shell. So this flow of electrons which causes the current to pass, electric current is produced. And how we can get this current? When we are actually placing electrodes, we can extract this current. These electrodes are placed in suitable position in the string. So by placing the electrodes in the suitable position, we can extract the current. So when we connect a load across these electrodes, we will get electricity through that path. So it is mainly, the function is like, the principle behind is Faraday's law. The difference is that the conductor which we are using is a liquid conductor or gaseous conductor. That is, the solid conductors are replaced by gaseous conductors or ionized gas. If such a gas is passed at a high velocity through a powerful magnetic field, a current is generated and can be extracted. This is another figure. Here you can see the electrodes from the ionized gas plasma is passed through the between the magnetic fields, and across the electrodes we are getting the DC output. So this the output voltage produces DC. So how we can convert it to AC? Using an inverter. And Fleming's right hand rule shows the direction. That is the EMF induced, that is the electric current, the motion of the conductor, that is a plasma current, and the magnetic field. These three will be right angle to each other, and we can find the direction of the electric current. And there is another figure showing the ionized fluid passing through the magnetic poles, getting the output voltage. So an MHD generator is a magneto-hydrodynamic converter that transforms thermal energy and kinetic energy into electricity. So thermal energy and kinetic energy is getting converted into electricity. MHD generators are different from traditional electric generators in that they operate at high temperature without moving parts. So we have studied in the earlier classes about traditional electric generators where we are using solid conductors. So in that case, the temperature is low compared to MHD. MHD has got very high temperatures and the moving parts is also less. There is no moving parts at all. The hot exhaust gas of an MHD generator can heat the boilers of a steam power plant, increasing overall efficiency. That means the gas coming out of the generator can heat the boilers, and thereby in a steam power plant using a steam generator we can get electricity. So it is actually increasing the efficiency. MHD was developed as a topping cycle to increase the efficiency of electric generation, especially when burning coal or natural gas. An MHD generator, like a conventional generator, relies on moving a conductor through a magnetic field to generate electric, and the principle is Faraday's law. It uses hot conductive ionized gas, that is plasma, as the moving conductor. The mechanical dynamo, in contrast, uses the motion of mechanical devices to accomplish this. So, as you all know, the working principle of a dynamo. So, it is a slight difference between MHD. The principle of MHD power generation. In MHD generator, the solid conductors are replaced by gaseous conductor and ionized gas. As we discussed earlier, if such a gas is passed at a high velocity through a powerful magnetic field, a current is generated and can be extracted by placing electrons in a suitable position in the stream. So according to Faraday's law, we are getting the magnetic field. Here in the figure, the magnetic poles, anode and cathode, ionized fluid passing through. This is the power cycle for MHD power generation. Actually, here we can see there is a combustion chamber and a generator chamber. So these two chambers are connected. The hot gases will be passed through the combustion chamber. In the combustion chamber, the hot gases will be passed, and through a nozzle it gets compressed. And also these hot gases are treated with an alkali metal like cesium or potassium. Why we are using this alkali metal like cesium or potassium? Because it has got high electrical conductivity and high ionization. Because of this high electrical conductivity, the gases coming out is getting ionized, and this ionized gas is getting passed through the MHD generator. And from this MHD generator, the gases coming out is given, the exhaust gases are preheated using a cooler. Air, like an air preheat, like in the other slides we can explain in detail. Actually, these gases are expelled and it is cooled, and again it is compressed and again heated, going to the MHD generator. The cycle continues. This is a power cycle for an MHD power generation, and the load means across the two electrodes we are getting DC current, and this DC current can be converted in AC using an inverter. So these are the four cycles. These cycles will be explained in the next session, in the next slides. So this is a construction of an MHD generator. Here you can see the working fluid which is passing through the chamber, the combustion chamber. It's a combustion chamber. The working fluid which is having in contact with the ionized, which is getting ionized using the alkali metal like cesium or potassium, and the ionized gas which is again passed through the nozzle. The blue color shows the nozzle, and this nozzle will be like convergent divergent nozzle. In this figure it's not clear, later on I will show you. So the nozzle which we use will be a convergent divergent nozzle. So from the divergent nozzle, what is happening is that the velocity will be very high if the nozzle is divergent, as its cross section is getting decreased. When the cross section is decreased, what is happening? The velocity increases. So this high velocity ionized gas is passed between the magnets, between the magnetic field. And what is happening? This ionized gas, the outermost electrons are getting expelled out, and this, because of this, outermost electrons are trying to, and these electrons will produce the electric current. And the electric current, which we can, how we can extract it? By using electrodes. By placing these electrons in suitable position of the stream, we can get output voltage. This is the construction. So it consists of a combustion chamber, generator chamber. The fluid conductor is passed in the combustion chamber where they ionize at very high temperature. There is a nozzle through which ionized gas passed into the generator chamber. The generator chamber consists of powerful magnet and number of oppositely located electrode pair inserted in the channel to conduct the electrical current generated to an external load. Both combustion generator chambers are surrounded by a heat resistance material and water cooler to repeat the cycle. This is another figure for the MHD power generation. Here you can see the fuel, and the fuel used will be like, the fuels just all coal, natural gas is burnt in the combustion chamber, and the air required for combustion is taken from the heat exchanger or from the preheated from the hot gases coming out of the MHD generator. The exhaust gases is given to the air preheater, and from there the air which we require for combustion is again given to the combustion chamber by a compressor. And there is an expansion nozzle, and the expansion nozzle, here you can see we are getting the DC power out of it, and this is actually a general MHD power generation figure for an MHD power generation. It's a general figure. It's working, it's explained here. That is, the gaseous fluid is passed into the combustion chamber through inlet, and by using a fuel like oil or natural gas or coal, the fluid conductor is heated to a plasma state, and hence it is ionized. And how it is getting ionized means by using this alkali. It is seeded with a alkali metal, a small amount of alkali metal. It is seeded with a small amount of ionized alkali metal, that is cesium or potassium, to increase electrical conductivity and ionization of the gases. In order to get the gases ionized, we are using this alkali metal. And how? Because in the combustion chamber the temperature is very high, that is around 2400 degree Kelvin. The temperature is very high. That means these gases gets ionized. The heat generated in the combustion chamber removes the outermost electrons in the fluid conductor. So this is how the electricity is taking place, because the outermost electrons is getting removed. Therefore, the gas particles and these gas particles acquire the charge. There is a flow of electricity. The charged particles, gas particles with high velocity, enters into the generator chamber via nozzle, that is a convergent divergent nozzle. The positive and negative charge moves to corresponding electrodes and constitute the current. And the direction of current is perpendicular to both the direction of moving gas particle and to the magnetic field. The direction we have explained in the previous figure, the Fleming's right hand rule. We can find out the direction of the current, which is perpendicular to both magnetic field and direction of motion of the gas particle. The electrodes are connected to an external circuit to get a load output. The current produced are direct current, and this direct current can be again converted into AC using an inverter attached with the external circuit. Next, we are going to discuss on the two types of MHD system, that is open cycle MHD system and closed cycle MHD system. So first we will discuss about the open cycle MHD system. Here you can see there is a two chambers, combustion chamber and generator chamber. First, the fuel is such as oil, coal, natural gas is burned in the combustion chamber, and the air required for combustion is supplied from the air preheater. Here you can see in the figure there is an air preheater, and the air preheater, the gas is coming out is preheated, and the hot air is again given to the combustion because the cycle has to repeat on. The hot gases produced by the combustion chamber are then seeded with a small amount of an ionized alkali metal, and the alkali metal here we are using a cesium or potassium to increase the electrical conductivity and ionization of the gas that I have discussed before. For the increasing the ionization of the gas, we are using a small amount of ionized alkali metals, cesium or potassium. The ionization of potassium takes place due to gases produced at a temperature of about 2300 2700 degrees Celsius. So the temperature in the combustion chamber is very high, that is about 2300 2700 degrees Celsius, and in the combustion chamber it is taking place. The hot conductive ionized gas plasma so produced leaves the combustion chamber and passes through a convergent divergent nozzle. See, here you can see a convergent divergent nozzle. So in the convergent divergent nozzle, what is happening is that the hot gas is coming out of the nozzle is at a very high velocity, and this high velocity is allowed to pass through the MHD generator. The gases coming out enters the MHD generator. Thereby, expansion of gases takes place in generators surrounded by powerful magnets. So, in the generator section, it is surrounded by two magnets. You can see in the figure, and the expansion of gases are taking place in the generator. So that means the outermost electrons get expelled out, and this movement of electrons, this charge carriers will be having electricity, and thereby the MHD generator produces DC current. So DC supply we are getting from the generator, and this DC supply, using an inverter we can convert it into AC supply, and to the power applications we are using this AC power. So for the household distribution power, everything we are using this AC power. And the hot gases coming out of this MHD generator, or the exhaust gases from the MHD duct, are used in air preheater to heat the air. There is an air preheater, and these hot gases are preheated, and actually the air is getting, the air which we are giving to the air preheater is getting heated using these hot gases. The exhaust hot gases are used to heat the air. Understand? And this air is given, this hot air is given to the combustion chamber, and the process is again repeating. So actually for the combustion process we require hot air. So the hot air is taken from the air preheater. Also, these gases can be used to produce using steam generator. Also, these gases we can use these gases in a steam engine to rotate its turbine. For that so that we can generate electricity again. In that way we can use. Also, this hot gases passes through a seed recovery unit. There is a seed recovery unit in the figure, and these hot gases are going to pass through the seed recovery unit. What is the function of a seed recovery unit? We can see the seed recovery unit is used for removing seeded alkaline potassium from gases. So already we introduced some alkali metals like potassium or cesium, right, for ionization. So these gases are poisonous. These gases has to be removed from the exhaust gases. So these gases has to be removed. We need to get clean gas in order to expel out into the atmosphere. For that we require clean gas. So the seed recovery unit is trying to remove the removal of this potassium, alkaline potassium from gases, and the clean hot gases are expelled to the atmosphere through a stack. Here you can see stack. From the stack we are expelling the hot gases into the atmosphere. And again these from the seed recovery unit, again the hot gases are again given to the nozzle. From the seed recovery unit, some of it is again given to the nozzle directly, because before removal itself it is directly giving. For removing the expel gas, we need to, for expelling the gases outside, we need clean gases. So we need to remove this seeds, this alkali metals from the gas. For that we are using a seed recovery unit. Before removing, we can use these for the after the combustion chamber in the nozzle we can use here for the process to repeat. I hope it's clear. Next is this is the explanation on open cycle system. Next is closed cycle MHD system. So what is the difference between an open cycle and closed cycle system is that here the hot gases or the exhaust gases are not expelled out into the atmosphere. This process is actually completing. That is why this is actually a cycle. That's why it's a closed cycle system. In a closed cycle system, a liquid metal is used here. A liquid metal, why we are using a liquid metal? Because it has got the basic advantage of high electrical conductivity. So high temperatures are not required in the system to achieve the high electrical conductivity. So here, as we are using a liquid metal like potassium only we are using, it's a liquid metal, and because of already it has got a very high electrical conductivity, the combustion chamber need not have very high temperatures. It can be operated at low temperatures also. It is designed to operate at low temperatures. The liquid metal used as working fluid in the system is potassium. So the liquid potassium, after being heated in the breeder reactor, so here we can see a breeder reactor. The breeder reactor is heating the liquid potassium and it is passed through the nozzle where its velocity is increased. Here you can see there is a nozzle in the figure, and this breeder reactors, actually the liquid potassium is being sent to the breeder reactor, and from the breeder reactor the vapors formed due to the nozzle action. From the nozzle action, the vapors are formed, and in the it is given to the separator, and in the separator what is happening is that it separates in the separator, and then from the separator it is given to the condenser. The separated parts are what we require for the electricity production. That part we are giving to the MHD generator, and the remaining part, the other separated part is given to the condenser, and it is again pumped, and it is given to the reactor, to the nozzle, and the process repeats. From the separator, the separated liquid metal, which is with high velocity, is passed through the MHD generator. So the separated portion is given to the MHD generator, and the remaining part is given to the condenser. And from the condenser through the pump and to the reactor, the process repeats. So from the separator, which is the liquid metal with high velocity, is passed through the MHD generator to produce the DC power. Here you can see the DC power, and again using an inverter we are getting electricity, AC power. And also the hot gases which is expelled using a heat exchanger or the steam generator, we can again generate electricity. And this system entails many construction and operational difficulties. It has got some operational difficulties also. So this is the working of a closed cycle system. I hope it is clear. Here you can see it has got a liquid potassium is used. Liquid potassium is heated in the breeder reactor, and through the nozzle again the vapors are formed and is separated, and the separated portion is given to the MHD generator, and the other portion is given to the condenser, and the process is repeated. The liquid metal with high velocity is passed to produce DC power, and the process repeats, and it has got operational difficulties. So the difference between open and closed cycle system. In open cycle system, working fluid after generating electrical energy is discharged to the atmosphere through a stack. In a closed cycle system, working fluid is recycled to the heat sources and thus is used again. See, the difference is that open cycle it is expelled, the hot gases, but here it is not expelled. The working fluid is recycled to heat the sources and thus is used again. It is again and again we are using. Second point, the operation of MHD generator is done directly on combustion products. In closed cycle, helium or argon with cesium seeding is used as a working fluid. So here we are using actually liquid methods. The temperature required in an open cycle is 2300 to 2700 degrees Celsius. In closed cycle, temperature required is just 530 degrees Celsius, because as we are using a liquid metal, it has got a very high electrical conductivity. Open cycle is more developed, closed cycle is less developed because of its operational difficulties and constructional difficulties. It is less developed. Some of the advantages are the on and off time is about second, so we are getting continuous power. There are no moving parts. It is very reliable to use. MHD generator has high thermal efficiency. It is a direct conversion device. They have better fuel utilization. It can produce large amount of power. The size of the plant is small. Some of the disadvantages are they need high pure superconductor. Working temperature is very high, as about 200 degrees Kelvin to 2400 degree Kelvin, especially in open cycle. The loss of power is very high. That is, the loss will be high if the power is high. The components get high corrosion due to high working temperatures. The components get corroded easily. The applications are the MHD generators are used to power submarines and aircrafts, electrical power production for domestic applications, and they are used in rocket for space applications. They can be used as power plants in industry and uninterrupted power supply system. Thank you all. And with this, we finished the MHD power generation. And next topics we will be taking in the next session. Thank you for listening.